Hi, Phil. I see you're getting ready for the tech meeting on the new Auto Temp system. I hear it really performs.
That's right, Jack. It's a second-generation system that maintains very precise control and is exceptionally stable in operation.
What's it like for servicing? Lots of new things to learn?
Not really. The previous one-piece control unit is replaced by a new servo assembly in the engine compartment and a separate amplifier inside the car. Also, a couple of units are eliminated. Most of the other parts work about the same as in the previous automatic system.
Well, that sounds encouraging. What's the story on the servo assembly?
Well, for one thing, it's powered by an electric motor drive, which is designed to move the servo blower and vacuum switches slowly. This slow movement stabilizes the operation of the system by preventing abrupt changes in system output. In addition, the blower and vacuum switches in the servo automatically move to a parking position when the off button is pushed or the ignition is switched off. With this arrangement, the blower starts at a low speed to prevent an unwanted blast of air from the outlets.
And the amplifier controls the servo. This sounds like a discussion that should be real interesting to all of our master technicians. Why don't you start over and give Auto Temp 2 the full treatment from the beginning?
Okay, Tech, but stay around. We'll probably need some help.
I understand that the heating, cooling, and air distribution sections of this system are practically the same as those used in our manual control air conditioning installation.
Correct. And that means that anyone who understands the manual control system should have no trouble with those parts of the Auto Temp 2. Now let's see how the systems differ. In the heater section, flow through the core is controlled by a water valve, but the valve in Auto Temp 2 is operated by the servo. A new cold engine lockout switch on the water valve keeps the blower from operating in the heat mode until the engine coolant temperature reaches 125. The main difference in the refrigeration section is at the compressor, which has a solenoid-operated evaporator temperature regulator valve instead of the pressure-operated EPR valve. There are also 3 compressor control switches, which I'll cover later on. As in the manual system, 2 vacuum actuators operate the heating, cooling, and defrosting doors. The separate air inlet assembly is also similar, except that the outside air door is controlled by a vacuum transfer switch.
The main thing to understand at this point is that Auto Temp 2 is essentially our manual control air conditioning system with automatic controls added to keep output at a selected comfort level. Now tell us about the controls, Phil.
For easier explanation, we can separate the automatic control system into 4 main sections: temperature sensing and selection, the amplifier, the compressor controls, and the servo assembly. The in-car sensor is affected by air temperature inside the car. It is located under a grill in the instrument panel where it is exposed to air drawn past it by the aspirator. The ambient sensor samples the temperature of the outside air. It is mounted on the inside of the dash behind the glove compartment and extends into the air inlet chamber in the cowl area. Both sensors are temperature-sensitive resistance devices which reduce electrical current flow when they are cooled and increase the flow when they are warmed. Their resistance is high when the temperature is low and low when the temperature is high. The temperature selector dial operates a variable resistance called a potentiometer, which works with the sensors and provides a manual setting for the desired comfort level in the car. When the temperature dial is moved toward the high side, the resistance increases. Toward the low side, resistance drops. The in-car sensor, ambient sensor, and control potentiometer are all connected in series. A resistance change anywhere along this line alters the current flow to the amplifier. When this happens, the amplifier signals the servo to vary the blower speed and, if necessary, to change the position of the air distribution doors and the water valve to provide and maintain the selected comfort level inside the car. As the servo operates, it turns an internal potentiometer which feeds current back to the amplifier. When the servo switches reach the position called for by the amplifier, the feedback cancels the input signals and the servo stops. How am I doing, Tech?
Real good, Phil. Now, why don't you backtrack and tell us some more about the amplifier?
Okay, Tech. The amplifier is a solid-state computer device which combines the signals from the sensors and other system controls to direct the operation of the servo assembly. It is serviced by replacing the unit.
You haven't said much about the compressor switch and the other compressor controls.
Okay, Jack. First, we have the yellow-colored compressor switch, which stays open until system vacuum is above 2 inches. This prevents compressor clutch engagement when the off button is pushed in. I'll get to the green-colored blower switch farther on. Next, we have the compressor ambient switch, which has a capillary tube extending into the air distribution housing to sample outside air temperature. The ambient switch contacts open and prevent compressor clutch engagement when the outside temperature is below 32 degrees.
While you're at it, don't forget the low-pressure cutoff switch that protects the compressor if the refrigerant level in the system drops too low. This safety switch is the same as the one used in the manual control system.
Thank you, Tech. Now, since all these switches are connected in series with the compressor clutch, the clutch does not engage when any or all of the switches are open. The clutch circuit is fed from the ignition switch through a 20-amp accessory fuse on the fuse block. The ETR switch is the final control unit in the compressor circuit. This is a temperature-sensitive switch with a capillary tube that extends into the evaporator fins. When evaporator temperature goes below 38 degrees, the switch causes the ETR valve to block refrigerant flow, so the evaporator will not freeze up.
When you check out the compressor circuit, you'll notice that all the other switches control current to the compressor clutch and the ETR switch. But this switch controls current only to the ETR valve. This wraps up compressor controls and brings us back to the servo. We've already covered servo operation in general, so now we're ready for the servo blower switch and the blower circuit. But before we get into that, mark this down in big letters. Do not tamper with the servo. The cold engine lockout switch can be replaced, but the upper section is off limits. Okay, Phil, you're on.
The servo blower switch is a limited rotation device with a switch arm driven by a two-way electric motor. The arm has an outer slider which contacts the blower switch segments. An inner slider maintains continuous contact, so the parking circuit can operate from any switch position. The switch segments provide 5 speed positions in the cooling mode section: high, 3 intermediates, and low. In the heating mode section, there are 4 speed positions, which produce the same intermediate and low speeds used for the cooling mode. The blower switch segments connect to resistor coils on a block in the air distribution housing. The switch connects the resistors in series step by step to produce intermediate speeds. When the highest speed segment in the cooling section is contacted, the step resistors are bypassed to produce maximum blower speed. Now, depending on the push-button control setting and the amplifier signal, the servo turns the blower switch to one of the speed positions on the cooling or heating sections of the switch, or it moves the switch to the park position.
I'm with you on the blower speed switching, but I need more on that park operation.
Well, as I mentioned earlier, the servo parks when either the push-button control or the ignition switch is in the off position. The servo can park after the ignition is off because the amplifier has a separate fuse-protected parking feed, direct from the main fuse block. You see, when all the other signals to the amplifier are shut off, only the parking feed remains. When this happens, the amplifier signals the servo, which moves to the park position and then shuts off. The servo switch arm parks on the cooling section's low intermediate speed segment. The servo switch moves slowly and may take up to a minute to reach the park position. So don't get worried if you hear the servo motor turning after you shut off the ignition. Now, the blower circuit also includes the green-colored blower master switch. This switch remains open until system vacuum is above 8 inches and prevents blower operation when the off button is pushed.
Okay, Phil, take a breather. We're at the turnover point on the record, so if someone will oblige, we'll continue with Auto Temp 2.
The servo vacuum switch works like the servo blower switch, but it controls vacuum instead of electrical current. As the vacuum switch rotor turns with the blower switch arm, Its ports line up to direct vacuum to the door actuators.
Well, that's easy to follow. But where does the vacuum transfer switch get into the act?
The vacuum transfer switch is actually a sliding spool valve, which controls the open positions of the air inlet door, locking the door fully open or 20% open as called for by the amplifier. To hold the door closed, push-button control vacuum bypasses the switch and goes directly to the actuator. The transfer switch has 3 ports, which are opened or closed by a sliding spool made of pliable material. An internal balancing spring holds the spool stem against the air inlet door so it can follow door movement. Here's how it all works. Since the transfer switch is bypassed by direct vacuum routing when the air door is closed, there is no vacuum at any of the 3 transfer switch ports. The closed air door holds the transfer switch stem in and leaves the spool lips clear of the ports. In any operating mode, when vacuum from the servo switch is routed to port number 1 of the transfer switch, it acts on the closed side of the inlet door actuator through port number 2, so the door starts to open. As the air door opens, the spool follows the door until its inner lip closes the number 2 switch port. This sealing action stops door movement and traps vacuum in the actuator line to lock the door in the 20% open position. When the amplifier signals for more outside air, servo switch vacuum is routed to the transfer switch. Servo vacuum is stronger than that trapped in the actuator line, so it breaks the lip seal at port number 2 and draws on the actuator to move the air door farther open. As the actuator opens the air door from the 20% position, the transfer switch spool moves farther outward, fully opening the number 2 port to servo switch vacuum. This moves the air door 100% open and locks it in that position until the amplifier calls for a change.
As far as I can see, that just about covers everything in the vacuum system but the check valves and the vacuum reservoir.
The check valves seal off sections of the vacuum circuits so the air doors and vacuum-operated switches can operate properly. The reservoir holds vacuum in the system for a period of time if the engine stalls or is shut off.
Don't forget to tell us how the cold engine lockout switch works, Phil.
Okay, Tech. Well, basically, the lockout switch prevents cold air output when heat is wanted. It is a simple bimetal strip which opens or closes a vacuum port in an airtight housing. The bimetal reacts to the temperature of coolant in the water valve.
As I mentioned earlier, the lockout switch can be replaced separately without affecting the rest of the servo assembly. But if you need a new servo, replace it complete with a new lockout switch. Okay, Phil? Now we can combine the operation of the electrical and vacuum circuits in a general roundup of what happens from the push-button end of the Auto Temp system.
To put it all together, let's begin with a few general facts about system functions, so we'll know what to expect in normal operation. When the servo parks, the water valve shuts off coolant flow through the heating core. This limits a moisture buildup in the air passing through the system and into the car. In addition, the compressor operates on any push button but off to dehumidify the air passing through the system. Of course, the ambient switch in the air housing prevents compressor operation if the outside temperature is below 32 degrees.
So the cooling system operates even in the heating mode.
That's right. The evaporator condenses excess moisture out of the incoming air before it reaches the heating core to help maintain an even comfort level in the car.
The higher blower speeds also get into the act when it's really hot and humid, especially in slow city traffic. The high air velocity keeps the car comfortable front and rear and pressurizes the car to clear out smoke. Now, on to the push buttons, Phil.
Pushing the off button parks the servo blower switch at the low intermediate speed position in the cooling section. However, the push button switch vents the vacuum lines to the master blower switch and the compressor switch, so the blower and compressor do not operate. On the off button, servo vacuum puts the air distribution doors in the cooling position, and spring tension holds the defroster door closed. push-button vacuum goes direct to the actuator and bypasses the transfer switch to hold the air inlet door closed. Now, with either auto button pushed in, the servo switches move to a cooling or heating mode position, depending on the signals that the amplifier receives from the in-car sensor, the ambient sensor, and the selector dial potentiometer. In either mode, the compressor clutch engages immediately if the outside air temperature at the ambient switch is near 32. However, in the heating mode, the cold engine lockout switch delays blower operation until coolant temperature reaches 125. Now, on low auto in the cooling mode, the servo blower switch arm moves to one of the 5 cooling section speed segments, as directed by the amplifier. High auto bypasses the 2 lower speeds and increases the upper 3 slightly above the top blower speeds in low auto. On both auto settings in the cooling mode, the air distribution doors are in cooling position and the defroster door is closed, the same as when the off button is pushed. On either auto button, servo vacuum closes the master blower switch, the compressor switch, and also holds the air inlet door open. Now, when the weather is hot and the amplifier calls for maximum cooling, the servo blower and vacuum switches operate mostly in their high-speed positions. This sends servo vacuum to the transfer switch by routing that locks the inlet air door in the 20% open position. For average cooling operation, the servo switches work in their lower speed positions. This changes the servo vacuum switch port alignment and routes transfer switch vacuum so that the air inlet door locks 100% open. Now, on low auto in the heating mode, the servo blower switch arm moves to the heating section of the switch where it contacts one of the 4 speed segments. High auto operation is limited to the 2 highest blower speeds, and here, as in the cooling mode, they are slightly higher than in low auto. On both auto button settings in the heating mode, servo vacuum moves the air distribution doors to the heating position, and the defroster door opens to the air bleed position. Under system vacuum, the compressor switch closes and engages the clutch, provided that the compressor ambient switch is also closed. If the engine is cold when in the heating mode, the blower does not run because servo vacuum is blocked off from the master blower switch. Vacuum is also blocked off from the transfer switch, so the spring in the inlet door actuator holds the door closed. As soon as engine temperature comes up to 125, the cold engine lockout switch opens and allows vacuum to go to the blower master switch and the vacuum transfer switch. The blower now operates, and the inlet air door opens as directed by the amplifier. Now for defrosting, on either the low or high defrost setting, control vacuum goes to the master blower switch and compressor switch to start up the system immediately. In both settings, the defroster door is open, the cooling door is closed, and the heating door is in air bleed position. The low defrost button provides essentially the same 3 cooling and 2 heating blower speeds available when on high auto. As in auto control operation, the air inlet door opens 20% for high outside temperature conditions, 100% for all other conditions. When the high defrost button is pushed, the sensors and selector dial are bypassed to signal the amplifier for full heat at the highest blower speed in the heating mode position. In this control position, the air inlet door is fully open.
We're running out of time, Phil. How about a few words on the Auto Temp tester?
The tester is essentially a plug-in substitution device which bypasses the sensors and selector dial to control the system manually. By switching, we can check system operation completely, regardless of the surrounding temperature. The vacuum test gauge samples vacuum at the blower master switch to indicate transfer valve and mode shift changes. The voltmeter is used to check the amplifier and servo, the sensors, and the selector dial. This new tester can be used only on Auto Temp 2 systems. Okay, Tech, did I finish on time?
Yep, you made it on time, but not quite to the finish. There's still more to be told about Auto Temp 2. So we'll have to tell it in the reference book for this session. Whether Auto Temp 2 is in your lineup or not, every up-to-date master technician should want to know what makes it tick. You'll find the complete servicing story in the service manual coverage of the system. We've got a different ending this time, so sit tight for the review that follows.